Hey guys, welcome back to another video. Today we are going to cover the question of palindrome linked list. So we are given a head of a single linked list and we have to return true if the given linked list is a palindrome, and if it is not, then we have to return false. So for the first example, as you can see, we have this linked list 1221, and if we read this linked list going forwards and going backwards, it is going to be the same. And for this, the output is true. So in a singly linked list, the challenge is that we can only move forwards. So if the head is at node 1 here, so we can only move forwards. So if we want to check for a palindrome like we do for an array using 2 pointers, like for example, if this would have been an array, then we could use 2 pointers and set I equal to 0 and j equal to length minus 1, and this way we can decrement j and increment I. But for a linked list, the challenge is we cannot really decrement, that is we cannot really move backwards for a singly linked list. So we cannot move like from node 1 to node 2. So let's see what we can do here. So the first solution we can think of is we can create a new linked list, which is the reversed of the input linked list. So we can create a new linked list and just reverse our input linked list, and then we traverse both the linked lists together because both the linked lists are going to be of same length, and we can check if there is a mismatch, we can return false, and if we reach null in both of them, then we can return true. So that would be one solution if we don't want to change the input linked list, and if we are allowed to change the given input. So what we can do is we can go till the middle node. So for this linked list of length 4, the middle node is going to be this node 2, and then what we can do is we can either reverse the first half or reverse the second half, and then we can traverse both the halves. So for example, if the first half is reversed, then 2.next is going to be 1. So my I pointer would be here, my j would be here, and I.next would move backwards and j is going to be moving forwards. If we reverse the second half instead, then also it's going to be the same thing. So for our optimal approach, we have to find the middle node, and then we have to reverse one of the halves, and then we can traverse both the halves together and compare the node values. One optimization we can use is when we are finding the middle node, we can reverse the first half along with finding the middle node. So this way we can do both these operations in one step, and then in the second operation we can traverse both the halves together and compare the node values. One more clarifying question to ask the interviewer would be that after this function returns, that whether we want to restore the input linked list to its original form. So for example, if we reverse the first half, so here 2 is going to point to 1. So if we just return from this function, then this linked list will be modified and it is going to change the given input linked list. So we might need to restore the linked list to its original form. So it is a very good clarifying question to ask the interviewer. For our approach, let's assume that we don't want to restore the input linked list and try to write the solution where we are finding the middle node and reversing the first half. So what we can do is we can start by writing a previous node and set it to null. And in our previous videos, we discussed about finding the middle node using slow and fast pointers. So we are going to use that here. So for that, I'm going to create slow and fast pointers. And as I am iterating over my linked list, what we need to do is, along with incrementing slow and fast, we have to set slow.next equal to previous and then move previous to slow. And that way we will be finding the middle node and also reversing the first half. So first we can set slow next and fast next so that we can set slow and fast later for the next iteration. And fast next is going to be fast.next.next. And now what we can do is we can set slow.next equal to previous and update our previous to slow. And now we can update slow equal to slow next and fast equal to fast next, and this way our slow pointer is going to point to the middle node of our linked list. Now there are two cases when the linked list length is odd and linked list length is even. To confirm whether linked list length is odd or even, we can simply make use of the position of fast pointer rather than finding the length of the linked list. So for even lengths, our fast pointer is going to be null, and for odd lengths, fast dot next is going to be null. So to confirm this, I recommend you to draw diagrams. I'm skipping drawing diagrams here because I've already covered finding the middle nodes in our previous videos where I covered this in depth. So please draw diagrams to understand this better. So next I can assign our 2 pointers. So I can create a left pointer, I can assign it to previous, and I can create a right pointer, and it would be assigned depending on our fast pointer. So if fast is null, this is going to be slow, and if it is not null, this is going to be slow dot next. So when it is null, then the position of slow pointer, it is going to be set to right. So for this case, our slow pointer would be this node 2. So right would be here and left would be here. And if this linked list would have been of length 5, so let's say there is node with value 3 here. So in that case, our slow dot next, that would be node 2. That would be our right pointer because slow would be node 3 then. So here we have left at node 2 and right at node 2 here, and our first half, it is reversed. So next we can simply compare the values of left and right pointers. So for that I can do a while loop where I'm checking while left is not null and right is not equal to null, and I can simply check if there is a mismatch, then we can return false, and if not, we can keep going till we reach null. Increment right equal to right dot next, and if we reach null, then we can simply return true and we would be done. So let's try to run this, and that got accepted, which is great. And let's try to submit, and yeah, that works, which is great. So I hope this made sense, and this is an easy problem, but it's not easy for those who are solving this problem for the first time, because you might not know the concept of slow and fast pointers, and you might even not know how to reverse the linked list. So before solving this problem, I highly recommend you to solve the problem of reversing a linked list and finding the middle node of a linked list. Thank you for watching, and I'll see you in the next video.